In this video, we're going to use trigonometry to find missing information in a right-angled triangle. The first thing we need to learn is how to label a right-angled triangle. So let's take one, and we're going to learn how to label each of its sides. Each of the sides of this shape has a special name that we assign to it. We're going to start by labeling the longest side, which is this one, and it's called the hypotenuse. The hypotenuse will always be opposite the right angle. In fact, we can turn the right angle into an arrow that will point straight at the hypotenuse. This might be a helpful way for you to remember where it's located. To assign names to the other two sides, we also need to mark an angle in this question, and there'll always be an angle in these trigonometry questions. So I'm going to mark this angle here at the top. I'm going to label it with this symbol here, which is a Greek letter called theta. We often use theta to represent angles. Now that we've labelled the angle, we can label the side that's opposite this angle, and we call it the opposite. This leaves the remaining side, which we call the adjacent. The word adjacent means next to, and that's because this side is next to the angle. It's helpful to abbreviate these to hyp, op, and adj. When I labelled the angle earlier, I chose the angle at the top, but I didn't have to label that one. What if instead I'd labelled the angle at the bottom? Well, this doesn't change the hypotenuse because that's still opposite the right angle, but it does change the opposite and adjacent. The side that's opposite the angle is now the one on the left-hand side, so we need to swap round the opposite and adjacent. Now that we know how to label the triangle, we need to look at what we call the trig ratios. These involve sine, cos, and tan. Some students mispronounce the first one as sin, but actually it's sine. The full version is S-I-N-E, and that's why we say sine. Cos is actually short for cosine, and tan is actually short for tangent. So we will call them sine, cos, and tan. Now you may have already spotted the sine, cos, and tan buttons together on your calculator. When we input these into a calculator, we always follow them by the angle, and the angle in this question is theta. So we could do sine of theta. Now it turns out for any right-angled triangle, if you did sine of theta, the angle that you're given, this will give you the same value as if you divided two of the sides, and those sides are the opposite and the hypotenuse. So we could say that sine of theta is equal to the opposite divided by the hypotenuse, and this holds for any right-angled triangle. Cos theta is slightly different. It's always equal to the adjacent divided by the hypotenuse. And tan theta is different once again. It's always equal to the opposite divided by the adjacent. These are known as the trig ratios, and you need to learn them for your exam. To help memorize these, we learn the phrase SOHCAHTOA. This is helpful because if we write them out like this, and then write the second two letters as a fraction, like this, it looks very much like the trig ratios on the right. So S, O over H helps us remember that sine theta is the opposite over the hypotenuse. C, A over H helps us remember that cos theta is the adjacent over the hypotenuse, and T, O over A helps us remember that tan theta is the opposite divided by the adjacent. Now let's have a look at how we use these to solve problems. So if we take this right-angled triangle here, we've got a missing side x on the left-hand side. The first thing we always do in a trigonometry question like this is label the triangle. I'm going to start by labeling the hypotenuse the one opposite the right angle. That's this 6 centimeters here. Then I'm going to label the opposite, which is opposite the angle given in the question. So this time we've been told the angle, it doesn't say theta, it says 39 degrees. And opposite that is this side over here, which has length x. The final side, the one at the bottom, is the adjacent. Then we're going to look at the information that we've been given. For the hypotenuse, we know it's 6 centimeters. For the opposite, we know it's x, and the adjacent has no other information with it. And it's the one that has no information that you're not going to need in the question. So we don't need the adjacent for this one. We're going to use the opposite and the hypotenuse. We then look over at SO, CA, and TOA, and we look for the one that has the opposite and the hypotenuse. And there will only be one. And that's this one here, which was sine. You can see it has O over H, which is the opposite divided by the hypotenuse. So now that we've selected the sine ratio, we write it out. Sine of theta was the opposite divided by the hypotenuse. Next we substitute in the values. Remember we said theta was the angle, so we're going to replace theta with the 39 degrees. Then we can see that the opposite is x, so let's replace op with x. And we know the hypotenuse is 6, so let's replace that height with 6. So we end up with this. This is now just an equation to solve, and we can solve it to find the value of x. On the right hand side we have x over 6, which means x divided by 6. So we're going to multiply both sides by 6 to solve this. If we multiply the left hand side by 6, we have 6 lots of sine 39. If we multiply the right hand side by 6, that will cancel the divide 6, so we just have x. We now know that x is equal to 6 times sine 39, and this part here can be typed into your calculator. If you type it into your calculator, it will give you the value of 3.77592 and so on. The question may tell us how accurate to give the answer. If it doesn't, we might want to just go to 3 significant figures. So this one would be 3.78 centimeters, and that's the value of x. Let's try a second example now. So for this one, we're going to begin by labeling again. I start with the hypotenuse opposite the right angle, that's the 9. I then look for the opposite the angle in the question, so that's over here, and the remaining side must be the adjacent. Then I look at what information I've been given. I can see I've got the hypotenuse, that's 9. I've also got the adjacent, that's x, but the opposite is all by itself, so that's the one I don't need in this question. So I look over at SOHCAHTOA, and I'm looking for the one that has an a and an h in it. And this time it's the second one, it's cos. So I write down the cos ratio. Cos of theta is the adjacent divided by the hypotenuse. Then I'm going to substitute in the values from the question. So theta is 53, the adjacent is x, and the hypotenuse is 9. Now I just need to solve this equation by multiplying both sides by 9. If I multiply 9 on the left-hand side, I get 9 lots of cos 53, and if I multiply by 9 on the right-hand side, the 9s will cancel and we have x. So we type this into our calculator, and that will give you the value of 5.416 and so on. Let's round this off to 3 significant figures at 5.42. Now let's try a third example. So we'll start by labeling. We label the side opposite the right angle as the hypotenuse. The one opposite the angle in the question, so opposite this 19, is the opposite. And the remaining one is the adjacent. Now we'll look at what information we have. We have the adjacent at 5.2. We have the opposite at x. But we don't know anything about the hypotenuse, so it's that we don't need in this question. So we do need to use the opposite and the adjacent. Looking at SOHCAHTOA, the one that has O and A in it is tan. So we write out tan theta is the opposite over the adjacent. And let's substitute those in. Theta is the angle, that's 19 degrees. The opposite is x, and the adjacent is 5.2. To solve this, we multiply both sides by 5.2. On the left, we have 5.2 lots of tan 19, and on the right, the 5.2s will cancel, so we have x. We type this into the calculator, which gives you a value of x as 1.79 and so on, and then we'll round this off to 3 significant figures at 1.79 centimeters. Now we're going to look at another example that's slightly different. So let's take this triangle here and we're trying to find x. We're going to start by labeling like usual. So the hypotenuse is the longest side opposite the right angle, that's this one here. The opposite will be opposite the 50, which is here, and the remaining side must be the adjacent. Looking at the information we have, we've got the hypotenuse as x, the opposite is 12, but we don't have anything with the adjacent, so that's the one we don't need. So we need to work with the opposite and the hypotenuse. Looking at the ratios, the one with O and H in it is sine. So sine of theta is the opposite over the hypotenuse. So let's substitute in the numbers. Theta is 50, the opposite is 12, and the hypotenuse is x. Now this is different to all of the questions that we've done previously. In the previous questions, the x was on the top of the fraction on the right hand side, but this time the x is on the bottom, and that changes our approach. What we're going to do is start by multiplying both sides by x. On the left hand side, this will give us x lots of sine 50. On the right hand side, the x's will cancel, so we end up with 12. Now we're trying to find the value of x, so we want x to be on its own. At the moment, we have x multiplied by sine 50. So to deal with this sine 50 on the left hand side, we could divide both sides by sine 50, remembering that sine 50 is just a number. So if we divide the left side by sine 50, the sine 50s will cancel, and we'll be left with x. On the right hand side, we need to divide 12 by sine 50, and we can just write that as 12 over sine 50. And it's actually this bit that we need to type into the calculator. So if you type 12 over sine 50 into your calculator, or 12 divided by sine 50, your calculator will give you the value of 15.664 and so on. If we round this off to 3 significant figures, it would be 15.7 centimeters. Let's try another example like this one. So we'll take this triangle here, and we'll label the sides. Let's start with the hypotenuse opposite the right angle. The one opposite the angle in the question is the opposite, and the remaining side must be the adjacent. So looking at this question, we've got the adjacent, that's x, we've got the opposite, that's 27, but we have no information about the hypotenuse, so we're going to not need that in this question. So we're looking for the one that involves opposite and adjacent, and that one's tan. So we write out tan theta is the opposite over the adjacent. So let's replace the theta with 28, the opposite with 27, and the adjacent with x. You can see once again we end up with x on the bottom of this fraction, so we're going to do the same steps as we did before. We multiply both sides by x. On the left hand side, that will be x lots of tan 28. On the right hand side, the x's will cancel, so we've just got 27. Then we have x multiplied by tan 28. So we're going to divide both sides by tan 28. On the left, we'll just end up with x, and on the right, we'll have 27 divided by tan 28, which is 27 over tan 28. We then take this and type it into the calculator, and that will give you the answer, x equals 50.779 and so on. If we round this off to 3 significant figures, we get 50.8. Sometimes in the questions, it won't be a side that we're finding. In fact, in this one, it's the angle that's missing. And we do this in a slightly different way. So we're going to start by labelling the triangle as normal. The 14 over here is the hypotenuse. The one opposite the angle is the opposite. And the remaining side is the adjacent. We still look at what information we have. So we have the hypotenuse here at 14. And we actually have the adjacent as well, that's 8. But we don't have any information about the opposite. So that's the one we don't need in this question. So we need the one with the adjacent and the hypotenuse, and that one is cos. So we write out the cos ratio, cos theta is the adjacent over the hypotenuse. Then we substitute in what we know. While this time we don't know the value of the angle, that's the missing information x. So we replace the theta with an x. Now the adjacent we do know, that's 8. And the hypotenuse we do know, that's 14. So we end up with this equation here, cos of x equals 8 over 14. Now remember the aim of this question is to find the value of x. And in the previous questions, x was on the right hand side in that fraction. But this time x is here, on the left hand side, and it says cos of x. Now we want to get to a point where on the left hand side we just have x and not cos of x. Now we can't use the strategies we used before to deal with this cos. You certainly can't divide both sides by cos or subtract cos from both sides, which is normally what people think at first. Instead, we need to use a special button on our calculator which does the inverse of what cos does. If you look at your calculator and look closely at the sine, cos and tan buttons, above them you'll see some smaller text, usually in yellow, that's inverse sine, inverse cos and inverse tan, and it has a little -1 there. We're going to need to use these buttons to solve this question. So what we do is we take the inverse cos of both sides. Now if we do the inverse cos on the left hand side, that will remove the cos, so we're just left with x. And on the right hand side, we need to do the inverse cos of 8 over 14. And we write that as inverse cos of 8 over 14, like this. And it's this that we type into our calculator. Let's have a look at how we would type this into the calculator. So if we take a calculator, and you'll notice at the bottom we have the sine, cos and tan buttons. Above those though, you'll see we've got inverse sine, inverse cos and inverse tan. And this one we need to use inverse cos because that's what it said in the question. To get to this, we need to press shift first, and then press cos. Notice how the calculator now has this little -1, that means we're doing inverse cos. Then we're going to press the fraction button to create our fraction, and then 8. Then we press down to get to the bottom of the fraction, and then 14. Then we can press right to get out of that fraction, and then close that bracket. If we then press execute or equals, this will give us the answer to the question. So the answer for this one is x equals 55.1500 and so on, and if we round this off, it'll be 55.2. Notice I've put a degree sign this time because it's the size of an angle, it's not the length of a side. Let's have a look at a second example like that one. So we'll start by labelling the sides. This 50 here is the hypotenuse, the one opposite the angle is the opposite, and the other one is the adjacent. You can see we have the hypotenuse and we have the opposite, but we don't have the adjacent, so that's the one we don't need. So we're looking for the one with opposite and hypotenuse, and that one is sine. So we write sine theta is opposite over hypotenuse. The angle in the question is x, so that replaces theta. The opposite is 30, and the hypotenuse is 50. So we end up with sine of x is 30 over 50. Now we need to use the inverse sign. So on the left-hand side, we'll just have x, but on the right-hand side, we'll have the inverse sign of 30 over 50. And it's this we need to type into the calculator. So let's take our calculator, and this time we're doing inverse sine, so we're going to press shift at the top, and then sine, and then we need the fraction button, and on the top of the fraction we have 30, and on the bottom we have 50. Then we can close that bracket, and then if we press equals, we'll get the answer to the question. So for this one, we have x equals 36.869 and so on, and if we round this off to 3 significant figures, it would be 36.9 degrees. Sometimes we need to use the skills we've learnt to solve even harder problems. Let's have a look at 2 of those now. So imagine we had this diagram here, and the question said, work out the size of angle x. So if we look at the triangle that has angle x in it, we can see it's a right angled triangle, which means we can use trigonometry. So let's take a closer look at that triangle. If we label the sides in the usual way, the 6 would be the hypotenuse, the one on the left-hand side here would be the opposite, and the one at the bottom would be the adjacent. So if we look at what information we have the hypotenuse, but we don't have the adjacent or the opposite. And we're also missing the angle x. Since we only have one bit of information for this triangle, we can't yet use it to find the value of x. So what if we take a look at the other triangle? Triangle ABD. Well, this triangle shares a side with the blue triangle, the length from B to D. So if we could find the length from B to D using this triangle, we'd be able to use it for the other triangle as well. And that's exactly what we're going to do. So we're going to take a closer look at triangle ABD. If we label this one, this side would be the hypotenuse, the 8 centimeters would be the opposite, and the remaining side is the adjacent. Looking at this one, I have the opposite, I don't have the adjacent, but that was the one we said we were going to find, so we're going to need to label that, and we'll use the letter y since there's already an x in this question. We don't have the hypotenuse, so we don't need it. So for this one, we can use trigonometry to find the length of BD, which we've called y. So if we write out SOHCAHTOA, this time we need the opposite and the adjacent, which means we need to use tan. So if we write out tan theta is the opposite over the adjacent, and then we'll substitute in the numbers. The angle is 61 degrees, the opposite is 8 centimeters, and the adjacent we have called y. So we can now solve this to find the value of y. To do this, we multiply both sides by y. On the left, this will be y lots of tan 61, and on the right, the y's will cancel, so we just have 8. Then we divide both sides by tan 61. This will give us y equals 8 over tan 61. If you type that into your calculator, it will give you this value here. So we now know the value of y is 4.434472 and so on. So I'm going to write that onto my triangle. Now if we return to the original triangle, the blue one, we can also label BD here as the same value, so 4.334472 and so on. Now you might be confused at this point as to why I haven't rounded that value. That's because we're going to use that value in a moment, and you can't round values too early in the question or you may end up with a slightly incorrect answer. You should only round off your final answer at the end of the question. So let's see if we can now use this triangle to find the value of x. So if we label the triangle, the 6 is the hypotenuse, the side DB that we just found is the opposite, and the one at the bottom is the adjacent. You can see we have the hypotenuse, we have the opposite, and we don't have the adjacent, so that's the one we don't need. So if we look at SOHCAHTOA, we're after the one with the opposite and the hypotenuse, and that is sine. So if we write out sine theta is the opposite over the hypotenuse. Then if we substitute in the numbers, so theta is the angle, and in this case that's x. The opposite is that number that we worked out, 4.434472 and so on, and the hypotenuse is 6. So to find the value of x, we do the inverse sine or 4.434472 and so on over 6. Now it's really important that when you type this into your calculator, you do use that whole number. Otherwise your final answer will almost certainly not be correct. It may be close to the real answer, but not accurate enough. You can either do this by typing out all of those numbers, or you can use the answer button on your calculator. So if we do this accurately, we'll find the value of x to be 47.65299 and so on. Now that we're at the end of the question, we can round the answer. So I'm going to go for 3 significant figures again, so it'll be 47.7 degrees. Now let's try one more tricky question. So in this question, we have a trapezium that looks like this. It says the perimeter of the trapezium is 47 centimeters, and we need to work out the area of it. To work out the area of a trapezium, you need to use the area formula, which is area of a trapezium is a half bracket a plus bh. Now this is on the formula sheet for 2024, but in most years you actually have to learn this formula. When using this formula, a and b are the parallel sides, so that's 20 and 5 centimeters. H is the perpendicular height, which will be this length here. And for this question we don't know h, but we're going to need to find it to use it in the area formula. So our goal is to find the height so that we can find the area of the trapezium. Since this is the perpendicular height, that length must make a right angle with the base. So here we have a right angled triangle. Let's take a closer look at that triangle. We're trying to find the height, which is the side on the left-hand side, so let's call that x. Now it doesn't look like we know any other information about this triangle, but there was a statement in the question that said the perimeter was 47 centimeters. Right now we know 3 of the lengths of this trapezium. We know the 5, the 13 and the 20. So if we add those together, we get 38. We know the perimeter needs to be 47 and 3 of the sides make 38, so if we subtract 38 from 47, we find the missing side is 9. So this side here must be 9 centimeters long, which is the hypotenuse of our triangle. So now let's go ahead and label. We've got the hypotenuse, which is 9, the opposite, which is x, and the other side here, the adjacent. We have the hypotenuse, we're trying to find the opposite, and we don't know anything about the adjacent, so let's lose that. Then if you look at SOHCAHTOA, the one with opposite and hypotenuse is sine. So sine theta is the opposite over the hypotenuse. Let's substitute in the values. So the angle is 50, the opposite is x, and the hypotenuse is 9. Now we can solve this one by multiplying both sides by 9. That'll be 9 times sine 50 equals x. So if we type this into the calculator, we'll find the value of x, and that comes out as x equals this number here. Now just like the previous question, we're not going to round that number yet because we're going to need it later on in the question. But we can now label on this height, which is 6.8943 and so on. So now let's return to the area of a trapezium formula. It's 1/2 times a plus b, which is 5 plus 20, times the height, which we now know to be 6.8943 and so on. So we just need to work this out. Now you could just type this straight into your calculator, making sure you use the full number for the 6.8943 and so on, or we could do 5 plus 20, which is 25, and then half of that, which is 12.5, so we need to do 12.5 times the answer that we got previously. And if you type this into your calculator, you'll get this value here. Now we can round this off since it's the final answer to the question, so 86.2, and the units are centimeters squared since it's area. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not give the exam questions in this video's description a try.